Packages. Now what we're going to do is turn our attention to understanding how Java groups classes together in what are called packages. Believe it or not, we've been really working with them for a while now. It's almost impossible to do anything in Java without using a package. So the first thing I want to start doing is understanding just what a package is all about. And then I want to start taking a look at how I can create my own package. And then what are we actually doing when we're importing packages? So let's go ahead and kind of revisit about what packages are all about and some of the packages that we've been using with the Java language. The entire Java API is organized into packages. Let me go ahead and open up my Java documentation, and let's just kind of review some of the main packages that we've been using for a while now. The most fundamental package is called java.lang. So I'm going to go into my Java and API language, and then we're going to go into Java 2 platform specification. All right. And here we can see we're at the main page, right? The index.html. Up in the top right, or top left corner, that is, you can see we have all classes, and then we have packages, java.applet, java.awt, java.awt.color, and then we've got down here java.lang. Over here in the main frame here, we can see we have a nice little explanation of what those packages are. And again, the most important package is java.lang. That is where all of the fundamental, the core design, the core classes used to write Java applications exist. And see if you remember what the main class is that every class in Java inherits from is java.lang.object. And java.lang.object is a class that is found in the java.lang package. Okay? Yes, some people might, be seeing that there's actually a package class too, java.lang.package. You're absolutely right. So we've been using these for a while now. So what I want to do is let's see the benefit of using packages by using some classes without specifying the package, and let's see what we get. Okay, let's get a little bit of practice utilizing packages. To start, let's kind of revisit with an old class that we've been using for a while now. And let's write an application that does some configuring and testing of the date class in order just to print out the current date to the standard output, the command prompt. So I'm going to create a class, public class, and I'm going to call it date test. And let me go ahead and save that as date test.java. So C Java packages, and we'll call that date test.java. All right, now let's go ahead and put in our famous main method, public static, void main, string. If you recall, string is an array, or args rather, is an array of strings. And I'm going to say date today equals a new date system dot out dot println today dot to string. Nothing too complicated going on here. But is there? Let's see. I'm going to save that. And let's jump out into the command prompt. And we'll go into my Java packages directory. And in there we'll see I've got a date test.java. I'm going to compile it. javac date test.java. Now we're going to get some errors. And you're going to see, in fact, that the compiler is complaining about that it has no clue about what a certain symbol is. Particularly, it doesn't know about the date class. It has no clue about it. It doesn't know where it is when we're going to instantiate it. You see here the little pointer is pointing to when we're declaring the data type today of type date. It goes, what is date? I don't know about that. And it's also complaining in a second place. Okay, so notice that it's complaining about where we're specifying this data type. It's also complaining about the constructor. It can't find the location of the constructor. Now, by default, it looks in the current path or the current directory first. So there is no date.class file inside, or there isn't a class file that contains the date class inside of the current directory. So what do? Well, there's a couple of things that we can do. Let's hop out to the Java documentation and recall that the the date class lives in a package called java.util. So I click on java.util, and then down here it'll bring up all the classes inside of java.util. And there it is. There's the date class. So the first thing that I can do to remedy this situation is I can fully qualify the class name in the declaration here by specifying the package. I also do that with the constructor, java.util.date. So I specify that here, and I specify it here. Recall that the compiler was complaining about this in two areas. The first one on line 5 here, where it was complaining about this part where we're declaring today as type date. You could see that little angle caret there. The second place that the compiler was complaining about it was here when we were calling the constructor. So now that I've gone ahead and made that little change, what I can do is recompile. So let's go into the command prompt and redo javac date test.java, and we should get our command prompt back just like that, meaning we compiled successfully. All right, that is one way of specifying a package by fully qualifying the path all the time. Now, that could become a little bit tedious. So let's take a look at another way of doing this. Same exact thing. The other thing I can do to remedy this, instead of specifying every single time I want to declare a variable of a certain type by specifying the fully qualified name, including the package, is I can use an import statement. The import statement goes right above class declaration, and we've been using this for a while now, but now you're going to start to see what in fact we've been doing. I could say import java.util.date. By saying java.util.date, I'm making a reference, if you will, to the date class in the java.util package. And now I could come back here and I can say date today equals a new date. And the reason why I can do that is because I've specified utilizing the import statement. So now if I do Java C, and I could just do star.java because that will hit all of the Java files in this directory, of which there's only one. You can see date test.java. It compiled, no problem. Okay, now what I want to do is kind of continue along this route using another class inside of java.util package. There's a special class called the vector, which is a collection class. It's like an array. And I'm going to say vector vec equals a new vector. Now, I'm going to save this and I'm going to compile it because I want to show a little example of what's going to be kind of going on here. I'm expecting an error. The error I got was exactly what I expected in terms of I can't understand what a vector is, or I can't instantiate it using the vector constructor. Now the question I'm hoping to raise is, why did that happen? Because you imported java.util.date. Well, that's kind of the answer. You see, I only made a reference to java.util.date. I didn't make a reference to java.util.vector. So I could remedy this in one of two ways. I could come here and do java.util.vector and java.util.vector there, save that and compile it. And let's recompile that. And then we'll just get our command prompt back, and you can see that compiled. That's the first way. The second way of remedying this error is by specifying a reference to the vector class too. Import java.util.vector. If I can get that down, save that, revisit our command prompt, and go ahead and compile that. We get our command prompt back, and you can see that's working. Now, we haven't been doing that. What we've been doing is, first of all, this can just get real tedious by importing every single class that you want down to the class level. Probably the better fix to do, and the easier thing to do, is just make a reference to all classes in the java.util package by using a wildcard character or the asterisk. Now I have a reference to all of this. So I could say Java, I could say date, I can say vector, and it will go ahead and find these. So let me save that and recompile. And we've been doing this the whole time. The first question that always comes back to me is, does this impair performance of the application? And the answer is not at all. This has nothing to do with performance of the application. This has everything to do with compiling. So the only time in my career that I would specify, or the only time really you have to specify the full path to this, to down to the class level, really is if you have two classes with the same name and they live in two different packages. Which brings me to another good point. you can only have one package with a class name, one class and one package. You can't have two classes with the same name in the same package. You would have to put those in different packages, and then you'd have to say something like, package one dot date, blah, 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 and package two dot vector. Also you'd have to put package one and package two here, respectively. That is really the only time you'll have to fully qualify the location of a class down to the package level is if you're trying to handle conflicts in names. So it's a really good idea to go ahead and import, java.util.star and take advantage of those wildcard characters. Okay, so now that we see how to use the packages and the import statement to access those packages provided by Java, how do we go about creating our own packages and employing those packages utilizing the import statement in our own Java applications? Well, let's take a look. We've got a couple of things to look at first here. The first thing that we need to understand is there's actually a special syntax for creating your own packages. Now, very easy to do this. Creating your packages is easy. There's one little tricky thing about it, but you're going to use the package statement. And there's some interesting things about the package statement I'll show you here in a few seconds. Then what we're going to do is if we want, and this is a big if here, okay? This isn't a must, but this is an if. So I'm going to mark this as an if. If we want our classes and constructors to be accessible outside of the package, then we have to mark them as public. Only if we want them to be accessible outside of the package. Believe it or not, we create a default package every single time you create a Java application. We've been creating our own packages this whole time. However, we've been using the default package and the default package scope. Now what we're going to do is start creating classes to be accessible outside of that. Something else I need to show you is how closely related the packages to your folder or directory structure. And then finally, when we compile packages or our source code, that is, and we want to use a package, we have to use the Java C compiler. Okay, we know that, Java C, but there's a -class path option that we have to go ahead and utilize when we're compiling and specifying the package. All right, so let's go ahead and put this into some practice. Okay, the first thing we're going to do is we are going to come into a directory that we like, and I've been working in my Java packages directory, okay? And what I'm going to do is I'm going to create a directory using the DOS command mkdir. Just note you do not need to do this in DOS. You can, click away in Windows Explorer, but I'm just a little bit more comfortable here. And I'm going to call this CBT Nuggets package. Well, just CBT Nuggets. That sounds good to me. And there is a directory. Now, what you have to understand is the directory becomes the package, okay? Not the classes inside of that directory. The classes are not the package. It is the directory that is the package. So now what I'm going to do is I'm going to create a class inside of that package. And I do two things. It's very straightforward. The first thing I do is I use the package statement. Now, the package statement must be, if you're going to use it, the first line of code other than a comment. Okay, so I could put, a Java comment here. This is a demonstration on creating packages and classes in those packages. Okay, I'm kind of typing here pretty quickly. That's a comment. Then, and this is an important order for you to remember, I'm going to save this here, and we'll call this, I'm going to put it in CBT Nuggets, and we'll call this CBT Nuggets 1.java. And even though I'm saving it inside of the CBT Nuggets directory, I have to say, hey, this is also the CBT Nuggets package. So here is the order. The first thing you have to do, the first statement, you can have as many comments as you want, but the first statement is that if you're going to have any imports and then class declaration, that is the order. If you're going to use all three, package, import, class. Otherwise, if you're just using two, you do import class, or if you're just using the class, you just say class. You can never mix this order up, okay? So if you are not using an import, which I'm not, so it goes package, then the class. Now, as I said earlier, if you want to be able to access this class outside of the package, you have to mark it as public. And I'm going to call this CBT Nuggets 1. Okay, this is the class. I also need to make the constructor public. So CBT Nuggets 1. All right, and we'll do this fairly simple. I'll do a system.out.println. You created a new CBT Nuggets 1 class. Pretty straightforward. Now what I'm going to do is we're going to compile that. And to compile this, let me go into the CBT Nuggets directory. I have to use a special command switch to the Java C, and it's class path. And what I do is I direct where it is going, the name of the path to the package. The package is the directory. So if this CBT Nuggets packet is the package, this package lives in /java/packages. Okay, so /java/packages. And then I can go ahead and say the name of the class, CBT Nuggets CBT Nuggets 1.java. Okay, and that will compile, and it puts in the information to say, the class lives in this package. Now, how do we go ahead and access this package? Well, we've got essentially three choices. we can, one, set up an environmental variable to the package. Two, we can go ahead and use the dash class path when we go ahead and run the application in Java. We could set the class path. And of the two, setting the class path is the preferable method other than modifying the environmental variable. Because I'm going to modify the variable, let me get out of that DOS prompt. Supposedly Microsoft has fixed that, but I haven't tested that. It's a good habit that anytime you change your environmental variables to quit and restart your command prompt. So I'm going to come into here and I'm going to go to my class path and I'm going to specify in here that I'm going to put in the C:/Java/packages path, because that is going to be where you can find classes. Okay, so I got that. Now what I'm going to do is come out here and let's kill this and watch what I'm going to do on purpose here. First, we're going to generate an error. So I'm going to say public class demo1. Okay. And let's save this. Notice where I'm going to save it. I'm going to save it in a different directory other than the CBT Nuggets directory. Let's just save it up here. So call this demo1.java. Okay, now I'm going to do a public static void main string args. Now I'm setting us up to have an error, so I'm going to say cbt nuggets 1 demo equals a new cbt nuggets 1. Actually, I don't even have to do this. I can just go ahead and call a new CBT Nuggets 1 because it's going to produce, output standard output. Now, think about this. What error do you expect to see here? Let's go into the Java packages directory. I'm thinking we're going to get the error about can't find the symbol, and then it's going to yell at us, like what we were getting earlier. So Java C demo1.java. Okay, let that think a few seconds, because it's not going to be able to find it. And look at this, cannot resolve symbol. This is exactly what I was expecting to get. And it's pointing to CBT Nuggets 1. All right, no problem. We'll watch this. I'm going to say CBT Nuggets dot, because this is the name of the package. That's the name of the package. Remember, let's just go into the directory structure here. So run and C:/Java/packages/CBT Nuggets. You can see, remember, you got to separate. Yeah, this CBT Nuggets, it is a directory, but Java also looks at it as something else called a package. And the C:/Java/packages path points to this package. Okay, so now that I've specified CBT Nuggets here, let me go ahead and save this. And let's recompile and see what we get. So Java C demo 1, I've specified the package here, and look at that. It compiled. Now I can do Java demo 1, and it will run. Hopefully I get something like, you create a new CBT Nuggets 1 class. Hurrah. Okay, so that's one way of doing of utilizing this, and that's by setting the class path. Now, believe it or not, setting the class path isn't the preferred method. The preferred method is to say set class every time you go ahead and call an application that needs a different class. And the reason why it's preferred is because you're not permanently altering the class path. Every time you call set path, what it does is it changes temporarily the class path for that command window session. So you would say something like, let's go into packages. It would say set class path, and then you'll say equals the first class path. Always do the local directory, that starts. Then something like c:/java/packages. Okay, now let's do a javac demo1.java. Let's see if that compiles. Remember, I took it out of the class path, and you can see it worked. If I just do a class path, so I mean, it's actually just say set class path, and I don't say anything, you can see that it's specifying the class path, the temporary class path. Now, again, the period here means the local current directory. Always look in the current directory, and then you can go ahead and look in the subsequent directories to find packages or classes. All right, so that is how to go ahead and utilize those. Now, there's even another cooler way of doing it, using something called extensions. And this was a brand new feature that came out with Java 2. And basically, it's a way of having a global access to packages that you create, which is a pretty neat thing to do. And you use something called extensions. And extensions have a .jar or jar file. They're basically Java archive files, and they're stored in a very special directory that was created for us when we installed the JDK called the ext directory. Let's take a look at where the ext directory is. So we installed the JDK, so I'm going to right click on my computer and say explore. And then we'll go into the C drive. And here's our JDK over here. I'm going to switch the view to details. Okay, it is. I like that. And we go into the JDK, and then we're going to go into the JRE, the Java Runtime Environment directory. And once we're in there, we're going to go into the bin directory. I know this is actually buried pretty deep, but here we go. It's in the bin ext, or actually we're going to go into the the library directory, and then we go into the ext directory. And these are available to us. Now, what's pretty cool about this is that any classes and packages that we have in the format of the jar archive file that we put in this directory is automatically accessible when we, compile or execute our Java programs. And the good thing about this is we do not need to specify the class path environmental variable or use the dash class path command line option when we go ahead and compile or execute our Java applications. Now, when I go ahead and create my jar file for a particular package, I have to make sure that I put the .class files in the directory structure with the same package name. Okay, I just can't say .class to an archive file. So let's say I want to store my CBT nuggets package in the archive. What I have to do, and again, this is once I've already compiled, I go ahead and I issue a special command. And then I'm going to plop it in there. So let's go back to my command prompt. All right, and go into cd java packages. And watch this. Jar, okay, Java archive, CVF. Let me do a jar/question. And let's see. C creates the new archive. CV generates verbose output. Basically, it just tells us what it's doing. And then F specify the archive file name. So jar CVF, and then we're going to create the jar file. So I'm going to call this CBT nuggets.jar. Okay, that is it. And then what am I specifying? I'm specifying CBT nuggets. These are the class files. Nuggets, there we go, /star.class. Now, we only have one in there, so it went ahead and created a manifest file, which is metadata about the jar file. And look at this. It said added CBT nuggets, CBT nuggets1.class. If I do a dir, okay, we can see that I've got CBT nuggets.jar. So let me go ahead and type start period here. And that will bring up Explorer for me. Here's my CBT nuggets.jar. I do a copy. Then I'm going to go into here. And I do a paste. Okay, quit that. Quit that. And then let's do a dir. Notice how, again, let me do a set class path. Notice that in here I have no reference at all to my CBT Nuggets package. Okay, so let's see if this compiles. Javac demo1.java. And because it's in that extension, according to the literature, it should work. And guess what? It does. And this is a very cool little trick. So Java demo1, and here in a few seconds I get you created a new CBT Nuggets 1 class. So that is creating jar files and using packages. In packages, we went over how to bundle up our own classes into something called packages. And we saw that a directory and a directory structure is tightly coupled with the packages that we create in Java. I showed you how to import packages using the import statement. I also showed you how to use the package statement to define that your class is within a certain package. Notice how the first thing, if you're going to use it, is package. Then the second is import, and then the third one would be the class, if you're going to be using class. Then I showed you a cool trick using the jar command. Jar CVF. Create the jar, verbose mode output, and then specify the file name. Okay? And then when you put that in, you create the jar file. The jar, it creates a .jar of your package, and you put that in the ext directory inside of the JDK, and that ext came with the JDK. It was created for you during the installation. So I hope you have found this informative, and I'd like to thank you for viewing.